Hello and welcome to my talk, A Red Teamer's Forecast, Cloudy with a Chance of Hacks. My name is Max Corbridge. I'm head of adversary simulation here at JUMPSEC. I have a background in traditional penetration testing, and then I moved into full-time adversary simulation. So that means I specialize in red teaming, purple teaming, threat-led pen testing, and also cloud hacking. Since about last summer, my team have been focusing very heavily on the cloud, and we've been seeing a lot of good progress in that time. We've done some fully native cloud red teams, we've done blog posts, conference talks, podcasts, certifications, and much more. So before we get started with the actual talk, I wanted to set the scene in terms of where we've come from. The year is 2005. A small company called YouTube has just been founded, and Prince Charles and Camilla have married, and the word glamping was invented for the first time. It's around this time that Amazon, under the branch of AWS, Amazon Web Services, started working on their very first cloud computer offering, which was called EC2, or Elastic Cloud Compute. What happened next, we all know. This is the public cloud computing market from 2008 through to 2020, and this feels very real world with what I experience every day talking to clients. It feels like nowadays almost everyone has some degree of cloud. We see a lot more organizations that are more in the cloud than they're not, and we're also having more and more conversations with organizations that are fully cloud native too. This poses the natural question, are we more secure now that we're in the cloud? And you would be forgiven for thinking so, because we hear lots of promising words when we're talking about the cloud, like containerization and DevSecOps and zero trust and multi-factor authentication. And so surely with all of these new technologies, we're not making the same mistakes that we've been making for the past 15 to 20 years on premise. And actually, I would say that is true. But what we've done by moving to the cloud is we've introduced new security challenges. First and foremost, responsibility, which used to be a very binary category, has now become a multifaceted grey area with different cloud vendors adopting different shared responsibility models, which means a lot of cases it's up to us as the clients to be able to understand what our risk is and where our responsibility lie. But not only that, we've also seen, for example, that logging, which is a core security mechanic, has become a premium feature in some estates. One of the biggest differences as well when we're talking about cloud environments is that they are publicly facing. We're going to talk a lot more about that and the implications of that down the line. With regards to the cloud as well, we are seeing a massive increase in complexity. And with increased complexity, there is more chances for things to go wrong. This is a screenshot from AWS's own documentation about creating an IAM role. You can see there are 11 different things to look at here. There are 52 different actions which you can prevent or allow. And this is one of 128 different services within this cloud platform. So you can see how, for example, adhering to the policy of least privilege access can become very troublesome when you're dealing with such a complex environment. However, it's not just one environment in most cases. A lot of the time when we're looking at sysadmins who maybe have an infrastructure or an on-premise background, they are not only having to deal with one set of IAM roles or one set of constantly changing features with constantly changing names or one API structure, but in most cases we're seeing a hybrid cloud environment in which multiple different cloud providers are being used. In that instance, we've now got a situation where someone with an on-premise or an infrastructure background is having to manage and stay on top of all of these different environments, which can become very troublesome. For the rest of the talk, I'm going to be talking more about the red teaming side of things, so I'm going to assume some degree of familiarity with the cyber kill chain using terms like initial access, lateral movement, and privilege escalation. So let's start at the start with initial access. How do we gain access to these cloud environments? Now, for some of you who've been around the block, you may be surprised to know that password spraying is now back on the menu, although it looks very different to the traditional password spraying. The fact that password spraying is now back is actually a result of several different factors all working in unison. Firstly, as I mentioned earlier, cloud estates are now publicly facing, which means although you may be blocked for example, a wrong password or no MFA, for example, you are still able to, as an attacker, validate if you have valid credentials using a publicly facing cloud portal. We also have the fact that most cloud providers are using emails and passwords to sign in. Emails are incredibly trivial to enumerate. We recently found that we're able to get, depending on the digital footprint of an organization, between 60 to 75% of a staff's email list just based off the public sources that we use. With a large target list like this, we have often found, and in every case through our engagements, we have found at least one person who has a predictably weak password. Normally, we're actually talking about a lot more than one. And even if you've got strong password complexity requirements, we also always find that there will be users who have the weakest password which fits those password complexity requirements, like password 1 or spring 2024 exclamation mark, for example. Now, a lot of people at this point would be saying, oh, well, we've got MFA, so we're fine. But In actual fact, although MFA is very useful and it can prevent many of these attacks, we are yet to see a completely bulletproof rollout of multi-factor authentication in an organization. A lot of the time, we are seeing users who predated the MFA requirement not being set up. We're seeing MFA devices not yet being enrolled, so we can enroll them ourselves. We're seeing conditional access policies, which sometimes don't require you to have MFA, as well as things like bring your own device policies. So the result of all of this is that we are now leveraging a new era of tools which are designed to exploit these behaviors. For example, we can see here Team Filtration and Graph Runner. I'll talk a little bit about Team Filtration in the next slide, but Graph Runner we'll leave for another day. So this is what we see when we're using Team Filtration, which is a common initial access and password spraying tool. In the first instance, you can see that we are rotating the IP address of every attempt that we do. This is really important because it makes it very difficult to block us, but it also makes it very difficult to attribute this to one person or a team of people or even one organization. In the second picture, you can see that we're attempting to spray the passwords. And in the third picture, you can see that we found a valid set of credentials. Now, this tool will automatically attempt to find if there is an MFA requirement when it finds credentials. Where there is an MFA requirement, it will then begin to look for any gaps in the MFA. For example, it will send 200-300 requests to different APIs with different user agent strings pretending to be coming from different devices to see if there's anywhere where MFA is not actually being required. In the final picture, you can see that we have found one of these gaps in MFA. In this instance, it's signing into Microsoft Teams on an iPhone, normally due to conditional access policies, does not require you to use MFA, and as such, we've connected the kill chain to the point where we've got an initial foothold in the environment. The second point around initial access is applications. Now, controversially, I actually think that application security is now more important than ever, and that's because of the way that on-premise and cloud-hosted applications work slightly differently. In an on-premise environment, a lot of the time you see what you can see on the right-hand side of the screen, which is an application which is being firewalled off from the corporate environment and also from the public internet. If you were to compromise this web server, in often cases you're going to be running as the service account for that web server, which means traditionally you've got very limited permissions outside of that one web server itself. I've often found in previous engagements as well that even if you were to compromise this web service account, you aren't able to even read information from around the file system, only from that one very restricted location, which is called the web root. And in almost all cases, you're not going to be domain joined, meaning that impact in terms of follow-on attacks is somewhat limited. Now, we compare this to a cloud-hosted web application. And this is due to something called the metadata service that it looks very different. Now, the metadata service is not of particular importance today. You don't need to know much about it or how it works. But the key thing to think about the metadata service here is that it is in all major cloud providers, and it's a publicly accessible URL which your non-human accounts, such as your web service accounts, are able to query and receive back information about themselves. Now, crucially, one of the things that you can receive back about yourself is the session token which you are using to authenticate to that cloud provider. If you're thinking like a red teamer here, this means that you could potentially use this to authenticate to the cloud environment as that web application. The difference here is that when we're in a cloud environment and we've authenticated to it, we now have an incredibly rich API with which we can use to query the environment, query what access we have already to existing resources, and also run a whole suite of different tools to be able to enumerate and look for common misconceptions. Finally, with regards to initial access, I'm going to talk briefly about it here. We're using a lot more modern approaches to initial access, so moving a lot of our, for example, email-based phishing over to instant messenger-based phishing, like, for example, Microsoft Teams or Slack. This topic and the vulnerabilities that we found in the Microsoft Teams is going to be explored in another conference talk later on this year. For right now, all that's important to know is that we've been using this approach and using Microsoft Teams over phishing, for example, for a long time. And this is something that we're seeing more and more commonly as organizations are moving away from email-based communications and more towards an instant messenger-based communication. Finally, we have an honorable mention here to misconfigured cloud storage. Now, the reason why this is an honorable mention is because in most cases, this is not going to be applicable to an individual client or an individual red team. But when you look at a wide net approach, this is something which is causing huge problems. This bit of research found recently that over 1.5 billion sensitive files were being exposed in public storage. A lot of the times they may contain, for example, connection strings or passwords, and if you're really lucky, maybe they have a session token in there. As I said, this is usually on a wider scale. You're unlikely to find everything aligning all at once on an individual client, but this is a massive problem, and it's something which we regularly see on a smaller scale with all of our clients as well. So we've got a foothold in the environment. Now what do we want to do? We're naturally going to be looking to move around the environment, escalate our privileges, and then build towards these actions and objectives that we're trying to achieve. For example, data mining or data exfiltration, whatever it may be. Now, one thing to note before we get into the specifically cloud side of things is that if you are using a hybrid setup, so for example, you have on-premise and cloud, in most cases, specifically with Active Directory and Windows, you're going to find that compromise and dominance of the on-premise environment will also lead to compromise and dominance of the cloud environment. This is due to a number of different things, but mostly when you're talking about, for example, Azure hybrid authentication, it doesn't matter which of the different hybrid authentication models you've gone through, it will always end up passing through a server called the Azure AD Connect server. And if you have permissions to that one server, even local admin permissions, you don't need anything particularly advanced. You'll be able to either sift the passwords that are going out to the cloud or reset the passwords of privileged accounts in the cloud. And so as a general philosophy, if you've got an on-premise environment that's being compromised, your cloud is probably at risk too. So moving on to the cloud-specific lateral movement and privilege escalation side of things. Firstly, I'm going to talk more about the Azure, and then I'll talk more about AWS, as those are the two most common cloud providers that we see. And this is really where one of the biggest differences that we've found with on-premise versus cloud red teaming comes. When you're thinking about on-premise red teaming, it's very much an exploit-centric, very implant-heavy, lots of defense evasion, and you have implants running on devices, for example. In the cloud, it looks quite different. A lot of the time we are using abuse primitives, which essentially default bits of behavior, default settings and configurations which can be abused. And here are some examples of those. First and foremost, we've got the fact that any user by default in Azure can invite a guest into that tenant. We've used this to establish persistence, and we've also used this in combination with the next one, which is dynamic groups, to escalate privileges. Dynamic groups are essentially a group where the membership of if you are a member of that group or not is down to if you satisfy a certain criteria. A common example is if you have contractors working with your organization, then anyone with the name of the contracting company in their email address will get added to a certain group. We found this exact scenario in a recent engagement and were able to invite a guest, and the guest had in the prefix of their email address, so before the @ sign, was the name of the contracting company, which met that criteria, and then we were added into that group and we inherited the permissions of those contractors as a result of that. Additionally, we have the fact that by default in Azure, any user can create their own subscription. Now, this is often a bit of a surprise when we tell clients this, and in some cases this can lead to further abuse down the line. Generally speaking, you have to set up your own billing. It doesn't fall under the organization's billing, but this may allow you to, for example, spin up resources in the context of that tenant, or you can use it potentially to bypass conditional access policies. We're also seeing that in most cases, app registrations are being enabled by default. So this is essentially when you consent for an application in the cloud to do something on your behalf. This can be thought of as a novel approach to phishing. Instead of getting them to run a payload, you can get them to consent to an application and therefore use permissions, access their mailbox, their calendar, or whatever it may be through that as well. We're often seeing as well, specifically with cloud native organizations, that there is a heavy reliance on SaaS or third-party applications. If we are to compromise a user which has permissions to access one of these, then we're able to abuse the OAuth integrations with those. And we recently used this to be able to move laterally actually outside of the cloud estate, escalate our privileges there, and then return back to the estate with elevated permissions. And this is a massively up-and-coming attack, which I think is going to come a lot bigger down the line as well. Finally, we've got the fact that in almost every organization we've seen public Teams channels are created in which any user can see the content and also any user can add themselves to. It's very common in our experience to not use access control properly when it comes to these environments, and sensitive data and sensitive working groups are often set up with anyone able to see that content and able anyone to access it. And as such, we've been using this to scrape usernames, passwords, etc. that are being sent in these groups. With all cloud providers, but specifically in AWS as well, we're often just abusing the actual cloud services. So let's say that we have access to a particular cloud service, we can begin to interact with it and use this to perform some malicious actions. We've been having a lot of fun, for example, with CI/CD pipelines. We recently used access to a CI/CD pipeline to be able to push code to that pipeline. We were then able to see that that code was being run by a cloud checking agent, which basically did a few checks on the code before it was run. Ultimately, that meant that we were able to issue commands to this cloud checking agent. And from there, we were able then to issue commands that would compromise that agent, and then we would be able to use that to fully enumerate the environment from the perspective of that code checking agent. and go on to perform further attacks from there. We've also recently been leveraging serverless functions, so AWS Lambda functions, to be able to do some interesting stuff, such as in a lockdown environment that should have no ability to exfiltrate data, we're able to package up the data in a certain way and then exfiltrate it over DNS. So again, leveraging the cloud service to do something that it wasn't intended to do, which ultimately allowed us to exfiltrate data, which should have been impossible. Just like you'll find lots of passwords and sensitive documents lying around on people's workstations in on-premise, you'll often find the same thing in the cloud with compute instances. So whether that's a virtual machine or an EC2 instance in AWS, we're often finding that there's data which shouldn't be stored on there, and we're able to access it and then steal that data from there. We've also got automation accounts, which are used a lot in also hybrid environments to be able to issue commands to multiple different virtual machines or on-premise infrastructure. A lot of the time, we're able to use this to compromise an entire range of machines all at once by pushing a malicious code that gets executed on them. Also, just like we're always finding credentials being stored in SMB shares on-premise, we also find the same in the cloud, and we're always finding credentials being stored in, for example, storage accounts and AWS buckets, S3 buckets, which are not protected and are being used incorrectly to store sensitive data that anyone can access. Moving on to the actions on objectives. So we've now got access, we've escalated our privileges, and now we want to cause some real world impact. We're going to focus on two here, one being data mining and the next one being ransomware. So data mining, specifically when it comes to Microsoft stack, has become far easier thanks to the likes of SharePoint. SharePoint is almost always being used incorrectly to store sensitive data that anyone can read. I urge you all to go back to your organizations and to just type the word password into your SharePoint and see what comes back. You'll be amazed how many people store password.txt or password.doc on SharePoint, which we can go and read. Similarly as well, we're often finding things like confidential data, which should be locked down and only accessible to certain people, being labeled as confidential and then being open to anyone within SharePoint. We've used both of these to be able to achieve actions on objectives towards the end of our cloud red teaming engagements. And finally, we'll talk about ransomware. Now, ransomware looks very different with regards to the on-premise and traditional ransomware in terms of how it actually works, but ransomware is very much still possible. And I would urge you to go and read this Invictus IR blog, which talks about a full attack chain of doing ransomware in the cloud. Super interesting, but again, ransomware is very much still alive and well in the cloud. It just looks quite different. Finally then, what are the conclusions and the takeaways from this talk? Well, as I said at the beginning, MFA is a huge problem, so check and double check your MFA. We're almost always seeing issues here. Secondly, review the permissions which your users have within the cloud estates. A lot of the time we're seeing sudo global admin accounts with, for all intents and purposes, have the same permissions as a global admin or a root account in AWS, but not labeled as such. Consider if you're using some of the abusable default settings, some of the abuse primitives that I was mentioning earlier, as these are often not required, but they do allow us a foothold or a way to escalate our privileges in the environments. Specifically, check the permissions belonging to your third-party apps, or their permissions in your estate would be under their service principles. This is something which even Microsoft themselves don't get right every time and actually led them to be breached recently. So it's extremely important and a massive supply chain risk to be aware of. If you're using Azure hybrid authentication, then make sure to double down on the Azure AD Connect server security, as this is really a critical system when it comes to hybrid authentication and also elevating your privileges from on-premise into the cloud. And finally, one thing that we find is often not the case is the same degree of attention being put on visibility and monitoring in the cloud. We are doing a lot more now cloud purple teams to help organizations with this, but generally it's not getting the same love as it does on premise. And I think it's just as important in the cloud, if not more important. Finally then, my parting bit of wisdom would be around the future of cloud red teaming, because as I mentioned today, a lot of what we're doing right now is very much in the abuse primitive world. But I think we're going to see more examples like this in which the actual core infrastructure of the cloud has been compromised, as with time, threat actors and red teamers alike are going to have to try harder as a lot of these different abuse primitives are being shut down. And I think we'll see an increase in the amount of actual vulnerabilities in the core infrastructure, like we have done on premise for the last 20 to 30 years, is going to happen in the cloud as well. Thank you very much.